All right, class, here we go. Warm-ups 1.1. Today we're going to take a look at some homework questions. I would say the most challenging question from your last night's homework, or last day's homework, was page 2, number 6D. It says to graph and label the vertex and the axis of symmetry. The problem with this question, guys, is initially the form of the quadratic is given in standard form, and that does not give us the vertex. That in fact gives us the y-intercept. So what information do we know about that? We know that a equals -1 and c equals 0. So the only important information is we know that the y-intercept equals 0. So on our graph, ladies and gentlemen, we know that point. But in order to find the vertex, in order to graph this, we need to do something called complete the square. That is something that should be familiar to you from grade 10. Basically, you take b divided by 2 and square it. If you remember doing that in the side margin, that is what we're going to take a look at. Okay, let me explain how to do that. The steps when you do completing the square is to, number 1, you factor a out of the first two terms. And once you factor that out of the first two terms, then you realize that you need to complete the square. So in order to get 3 terms to complete the square, you do a side margin over here. And you take b and you divide it by 2, and then you take that value and you square it. So in this case, we have 9. That is the number you're going to add and subtract in order to keep things balanced with your equation. Once you have 3 terms that we're going to use to complete the square, we realize that this -9 is no longer part of our perfect square. So we bring it outside the brackets here. But remember, when you bring it outside, you have to multiply it by a, which is -1. So -9 times -1 becomes +9. Then we take a look at completing the square. So that becomes your binomial squared plus 9. And so our vertex, now that's in vertex form, guys, we know our vertex is 3 and 9, or P and Q, or H and K. So that's the point we plot right here, ladies and gentlemen, 3 and 9. Then we use our step pattern to help us plot this. So from that point, we take a look at our step pattern. So A is -1, so we sub it in. We now have a step pattern of -1, -3, -5. So as I move left 1, I go down 1. As I go left 1 more, I go down 3. As I go left 1, I go down 5, and it gets us to the y-intercept. If I go to the right side of the vertex, I go over 1, down 1, over 1, down 3, over 1, down 5. Okay? And the last question that it asks us to do, folks, is to take the symmetry of the axis of symmetry. So in this case, ladies and gentlemen, the axis of symmetry is from the vertex going down. So this is your axis of symmetry. And the axis of symmetry occurs at x equals 3. So whatever value is first in your vertex, that becomes your axis of symmetry. Second part, B, and this may not be from your homework, is to use this function to answer the following questions. A, state the vertex. Good news is, ladies and gentlemen, it's in vertex form. So the vertex here is -4 and 9. B, state the equation of the line of axis of symmetry. It is x equals -4. It is always going to be x equals b. Remember that from grade 10, hopefully. Next is to state the direction of opening. It is downward because A is negative. Okay? Now, in part D, describe the transformations from y equals x squared. Again, you take a look at what A equals, what P equals, what Q equals. So A equals -3. The negative part tells you it opens down, and the 3 part tells you that it gets narrower by 3. We're then going to call that a vertical stretch by a factor of 3. Okay, vertical stretch by a factor of 3. P is -4, which means it moves to the left 4. And Q equals 9, which means it goes up 9. E, state the optimal value. That's your min-max value. Also state if there is a minimum or maximum. Optimal value in this case, folks, is a Q. Okay? So looking at your Q value, it is 9. We have a maximum because it opens upside down. So remember, if it opens down, you have a maximum. But if your vertex or your parabola opens up, your vertex is at the bottom and you have a minimum. Okay, I apologize, spelling error. Here we go, let's fix that. Minimum. Okay. A couple more questions here. F is state the step pattern, so it's A times 135. So subbing it in, you're going to have a step pattern of -3, -9, -15. And to graph it, you use the vertex, which we know is -4 and 9, and your step pattern. Okay, so over here, ladies and gentlemen, we plot our vertex, which is at -4 and 9, and we use our step pattern. So as I go left 1, I go down 3, left 1, down 9, and left 1, down 15. It just doesn't fit on my graph. On the other side, you do the same step pattern. Over 1, down 3, over 1, down 15, and, down 9, and over 1, down 15. And you draw your parabola as best as you can. Notice it's a little thinner. It's been stretched vertically. So basically, it's been stretched left and or upside from the top and the bottom. Okay? Let's get to today's lesson. All right, so today's lesson is 1.1, relations and functions. A relation is a set of ordered pairs where the values are independent are paired with the values that are dependent. Okay? The independent variable, which we usually call x, is freely chosen. So in the past, you probably chose -2, -1, 0, 1, 2. It is graphed on the horizontal. Whereas the dependent variable, which depends on your x, is graphed on the vertical. You may have remembered from grade 9 or grade 10, the input is x, and you input x into the equation to get your output, which is y. Now we're going to change gears a little bit, ladies and gentlemen, and talk about a function. A function is a special type of relation where each of the independent variable x corresponds with only one value of the dependent variable y. The short form for that is each x has only one y. Taking a look at a mapping diagram, question is this a function? Looking at mapping diagrams, folks, it may be new to you, but just think of it as a table of values. Okay? It just looks differently. So if we have x, you have x of 4 and an x of 16 and an x of 1. In each case, does x have its own y? And I'm going to focus on first coordinate here, which is 4. When you have x, y can either be 3 or it can be 1. In this case, that tells us that no, this cannot be a function because one value of x has two answers of y, and you cannot have that. So that's when you say no, it is not a function because the x does not have one y, it has two y values. Taking a look at example B, ladies and gentlemen, again, x and y coordinates here. We take a look, each x has its own y value, and so yes, this is a function because each x has its own y. Just to make a special note here, folks, that when you see y equals 3, it's okay that x has a value of 2 and 4 to get that. However, notice that the arrows do not start together, they end together. Now, hopefully you remember this from last year, a vertical line test. This is how you test to see if it's a function. Okay? So vertical line test, what you do is take a look at a vertical line and you shift it from left to right to see if it is a function. So let me just hopefully draw a line here quickly and see if it'll work. Okay? So if I've got a straight line here, ladies and gentlemen, I'm going to select it, and as I drag it from left to right, it should only hit the graph once. Notice here, ladies and gentlemen, it hits it here, and here. So in this case, this is not a function because it does not pass the vertical line test. In example 2, ladies and gentlemen, let me draw a straight line here and see if I can drag it across. As I go, as I go from left to right, ladies and gentlemen, what do we notice? In each case, it's only hitting that line once. So in this case, yes, this is a function because it passes the vertical line test. I apologize, I got shifting here. Okay, so everybody okay with that? All right. Now, equations. How do we tell if equations are functions? This is probably the hardest one. And how can we tell it's a function? Is we take a look at what the graph looks like. So envision what the graph looks like. First example, hopefully you recognize that that is a quadratic and it's in vertex form. So basically you realize, hey, that's a parabola. And what do we know about parabolas? Is yes, they are functions because they will pass the VLT when graphed. Taking a look at our second example, it's a linear function, so what do we know about it? That it is a line. All lines pass the vertical line test with the exception of one. The only exception where a line is not a function is if it's a vertical line. Okay? How can you tell, ladies and gentlemen, what the equation looks like? How can you tell if you've got a vertical line? It will say x equals 5, for example, or x equals -2. So the only exception for a line to not be a function is if it's a vertical line, because it will not pass the vertical line test. All other lines will pass the vertical line test. Okay? And the last example, hopefully you remember C. Recognize that. That is x squared plus y squared equals r squared. That hopefully you recognize is the formula for a circle. So if I was to quickly draw a circle and try to do my vertical line test, what would happen here, folks? You would see that, hey, it hits my line at more than one spot. So then no, this is not a function because it does not pass the vertical line test. Here ends our lesson for today, folks, and our homework is page 10, numbers 1, 2, 4A, 6, and 9. Have a great day.